A single leg of Iberian ham can cost more than $4,500, making it one of the most expensive meats on earth. According to Insider, each leg spends up to 5 years curing before it is ready to serve. But behind the luxurious price tag, there's a hidden secret that many producers don't want you to know. Behind that price lies a slow, precise craft that begins with pigs wandering across Spain's oak forests. They eat over 20 pounds of acorns every day, walking miles to build the marbling that defines this rare meat. Inside cold cellars, air, salt, and time turn those legs into something prized by chefs and collectors alike. Every batch is tracked, tested, and aged to perfection under constant supervision. Today, we step inside the factory to uncover the full journey of Iberian ham. Do you think there could be any scandal with this luxury delicacy? Centuries ago, Spanish farmers discovered that salt, air, and patience could preserve pork through the long winters. The Iberian black pig, native to the Iberian Peninsula, became the heart of this craft. These pigs roamed open oak forests, feeding on fallen acorns that shaped their rich, nutty flavor. Over time, curing evolved from small village cellars to modern facilities with precise climate control. Yet the principles never changed: natural drying, long aging, and close supervision by skilled artisans. Today, Iberian ham remains a symbol of Spain's rural heritage and culinary pride. But how does a traditional craft turn into an industrial process that still keeps its soul intact? The process begins long before the factory. Iberian pigs are raised in wide oak pastures known as dehesas across western Spain. Each pig can walk up to 16 kilometers a day, searching for acorns that fall from the trees. During the Montanera season, from October to March, they eat up to 20 pounds of acorns daily, gaining weight naturally. These acorns are rich in oleic acid, the same healthy fat found in olive oil. It melts into the meat and creates the signature marbling of Iberian ham. Every farm records the pig's diet and exercise, ensuring traceability for each animal. The calm environment and slow growth rate allow the fat to penetrate deep into the muscle, producing a soft, nutty aroma. Once the pigs reach about 170 kilograms, they are sent to specialized facilities for processing. But what happens next that makes this meat different from any other pork? After slaughter, the hind legs are trimmed and shaped into the classic V-cut that identifies Iberian ham. Workers remove excess skin and fat using sharp knives before the legs are chilled to 0 to 1 degree Celsius. Cooling helps salt penetrate evenly during curing. Each leg is then buried in sea salt for about 15 to 20 days, depending on its weight. A 26-pound ham, for example, stays in salt for around 13 days. The temperature is kept just above freezing, while humidity stays close to 90%, preventing the surface from drying too fast. Salt draws out moisture, tightens the fibers, and protects the meat from bacteria. Once cured, the legs are hung for draining and checked one by one for consistency. The process is simple yet crucial. A single mistake here can ruin months of work. How do workers bring the ham back to its natural form after being packed in salt? Once removed from salt, the hams move through a conveyor line for cleaning. Brushes remove excess salt, and jets of high-pressure water wash the surface until every grain is gone. Then the legs are placed into mechanical presses that squeeze and mold them into a uniform, aerodynamic shape. This step helps the meat dry evenly and prevents air pockets from forming. Skilled workers inspect each piece, tapping it to check firmness before applying a layer of Iberian lard. This coating locks in moisture and slows dehydration during the next long stage of drying. The smell inside the plant is rich and savory, with a faint trace of sea salt in the air. Every leg now carries its own tracking code that records date, weight, and origin. The next phase will decide the ham's texture and depth of flavor. But how do factories control nature itself inside a building? The hams enter drying chambers that mimic the mountain air of Spain. The temperature starts at 3 degrees Celsius with 90% humidity, then gradually rises over 90 days. Large fans exchange warm and cool air, while digital sensors track moisture loss every hour. This slow process allows fat to melt slightly, soaking into the muscle and creating that smooth, buttery taste. Air ducts adjust automatically when humidity rises, ensuring consistent drying without cracks. The factory floor hums with the sound of fans and the faint rustle of hanging legs shifting in the breeze. Each room follows a seasonal pattern: cold in winter, warmer in spring. By the end, the hams lose almost 10% of their weight, signaling that moisture has escaped evenly. But drying is only half of the transformation. Where do they rest next to develop their famous aroma? After initial drying, the hams are moved to stone cellars that hold over 150,000 pieces at a time. The temperature here stays between 14 degrees Celsius and 25 degrees Celsius, shifting naturally with the seasons. The air is heavy with the scent of aging meat and oak wood. Over the next 2 to 3 years, enzymes inside the ham slowly break down proteins and fats, creating hundreds of aromatic compounds. Beneficial molds form on the surface, protecting the meat from harmful bacteria and adding depth to its flavor. Workers carefully monitor each rack, cleaning and rotating the hams to balance airflow. The color deepens from pale red to a rich mahogany, while the texture firms up without becoming dry. This long wait is what transforms simple pork into a luxury delicacy. But how do producers decide when a leg has finally reached perfection? Master ham graders perform the final inspection using sight, touch, and smell. They press the ham near the bone to feel its firmness, then use a thin probe made of cow bone to test the aroma. Each leg is marked according to quality. Black labels for 100% acorn-fed Iberian pigs, the highest grade. Hams that pass inspection move to the slicing room. Machines debone, trim, and slice up to 6,000 pieces per hour, placing them neatly on trays. Vacuum sealers remove oxygen to preserve color and freshness. Every package is printed with its batch number and curing date for full traceability. The finished products are stored at 18 to 20 degrees Celsius until shipment to gourmet stores around the world. What started as a pig in a quiet pasture has become a global symbol of craftsmanship and patience, one slice at a time. Every year, South Korea produces more than 2 million tons of kimchi, enough to feed the entire population several times over. According to Statista, this traditional dish remains one of the country's most valuable exports, worth nearly $100 million annually. Yet behind the jars of spicy, crunchy cabbage lies a process that dates back over 2,000 years. What once began in clay pots buried underground has now evolved into a high-tech operation powered by industrial mixers, airtight fermenters, and automated cutting machines. Each batch must maintain perfect balance, salt, spice, and temperature to protect the good bacteria that give kimchi its signature sour bite. Today, modern factories produce thousands of jars a day while still preserving the flavors that families have passed down for generations. So how do they transform fresh vegetables into a living food that can last for months? Kimchi began over 2,000 years ago as a simple method to preserve vegetables during harsh Korean winters. Early versions used salted radishes and cabbages stored in clay jars buried underground, where the cool soil controlled temperature and moisture. When chili peppers arrived from the Americas in the 16th century, Koreans added them to create the red, spicy flavor known today. Over centuries, regional recipes evolved, blending local seafood, garlic, and rice flour paste. What started as a survival food became a national identity. Today, factories still follow the same basic principles of salting and fermenting, but how do they scale it up to feed millions? The process starts with selecting only the freshest Napa cabbage, carrots, and scallions. Each vegetable is carefully inspected as it enters the factory. Workers remove wilted leaves, bruised spots, and dirt by hand before sending them through rotating brush washers. These stainless steel machines rinse the vegetables with cold, filtered water at a rate of 1,000 kilograms per hour. A second rinse ensures that no sand or residue remains. The clean cabbage heads are cut in half, revealing bright, crisp leaves. Carrots and radishes are peeled and sliced to uniform size. Quality controllers monitor the flow to guarantee that every piece meets visual and sanitary standards. The air inside the washing area feels cool and moist, filled with the scent of fresh greens. Once clean, The vegetables move along conveyor belts to the next stage. How do they turn these clean vegetables into the fiery red mixture recognized worldwide? At this stage, speed and precision matter most. Automatic shredders slice carrots and radishes into thin, even strips, while hydraulic cutters chop the cabbage into wide, flexible leaves. The vegetables fall into large stainless tubs where mechanical paddles toss them with sea salt. Salting draws out excess water and softens the texture. It also creates the first layer of protection against bad bacteria. The factory keeps the temperature around 10 degrees Celsius to prevent premature fermentation. After about 3 to 4 hours, the vegetables release nearly 10% of their weight in water. This salty brine helps later stages blend smoothly. Excess liquid is drained through perforated drums while the cabbage retains its natural crunch. Workers check the salinity using handheld sensors to maintain about 3 to 7% salt concentration, depending on the recipe. Once the vegetables reach the perfect balance between firmness and flexibility, they are ready for seasoning. What gives kimchi its distinctive red color and bold aroma? The answer lies in the spicy paste that defines every batch. Industrial mixers blend together pureed garlic, minced ginger, onion, chili flakes, and fermented fish sauce. The most essential ingredient, gochugaru, gives kimchi its vibrant red color and slow, warm heat. The paste's texture must fall between wet sand and soft mud, so the machine adjusts its speed to reach uniform thickness. At 20 degrees Celsius, the flavor compounds start combining, creating the base aroma. Each batch is measured to the gram using digital scales, ensuring consistent flavor across thousands of jars. Workers add a dash of sugar or plum extract to balance the salt. The smell inside the mixing room is sharp and tangy, with notes of chili and garlic. A technician samples the paste for acidity and moisture before releasing it for blending. The next step combines all ingredients into a single living mixture. But how do factories make sure every leaf gets coated evenly with this spicy blend? The shredded vegetables meet the spicy paste in large rotating drums that can hold up to 500 kilograms at once. As the drum turns, soft paddles fold the mixture slowly, ensuring that every surface is covered. Cameras and sensors monitor the color distribution to confirm even coating. The result is a vivid red mix that looks identical to homemade kimchi but made on a massive scale. The mix is then portioned into fermenting containers. Each is filled carefully to remove air pockets that could cause spoilage. Weighted plates press the vegetables down, releasing trapped liquid and creating a natural brine. The lids seal tightly, and water-filled moats along the rim keep oxygen out while letting gases escape. The sealed jars stay at room temperature for 3 to 5 days, depending on humidity and batch size. Inside, lactic acid bacteria begin converting sugars into natural acids, giving kimchi its sour depth. When the fermentation reaches the right acidity, it is time to lock in that flavor for months. The fermented kimchi is gently transferred into glass or plastic jars using pneumatic fillers that prevent air bubbles. Each jar is weighed to ensure consistent volume and then vacuum sealed to block oxygen. Automated cappers twist on lids at 60 jars per minute, followed by heat sealing for long-term freshness. The filled jars move through a cooling tunnel set at 4 degrees Celsius, where they stabilize before labeling. Conveyor lines carry the jars to an automatic printer that stamps production codes and expiration dates on each lid. Finally, cameras check the alignment of every label before boxes are sealed for shipment. Stored under refrigeration, the kimchi continues to mature slowly, deepening its flavor for up to 6 months. From field to factory, every step honors a 2,000-year-old tradition while using modern science to keep it safe and consistent. And as each jar leaves the production line, one question remains. How does something so ancient still taste so alive today? Every day, factories around the world produce more than 3 million sushi rolls, ready to be served in supermarkets and restaurants within hours. According to Nikkei Asia, modern sushi machines can shape up to 4,000 pieces of nigiri per hour, matching the precision of skilled chefs. Inside large production kitchens, rice, fish, and vegetables move across conveyor belts under strict temperature control. Laser scanners check color and freshness, while robots press, fill, and slice rolls with millimeter accuracy. Each movement is timed, each slice identical. The result looks handcrafted but is fully automated. What began as a centuries-old street food has become one of the most advanced food productions on Earth. But how do these factories combine delicate tradition with cutting-edge technology to make millions of perfect rolls every single day? Sushi began as a method of preserving fish in fermented rice more than 1,000 years ago in Southeast Asia. Over time, Japan refined the technique, replacing months of fermentation with fresh vinegar rice known as shari. By the 19th century, street vendors in Edo, now Tokyo, served nigiri sushi, quick bite-sized pieces made to order. This innovation turned sushi into Japan's first fast food. When it reached the United States in the 1960s, machines soon followed, designed to meet growing global demand. Today's factories blend that same tradition with automation, turning centuries of craftsmanship into precise engineering. But how do these machines shape, fill, and slice sushi with such perfect consistency? Every sushi roll begins with rice, and its texture decides everything. Industrial washers handle up to 200 pounds of rice per hour, rinsing each grain several times to remove surface starch. Clear water means the rice is ready. The clean rice moves into automated cookers, where sensors control temperature and timing within a margin of 1 degree. Steam fills the air as each batch cooks at around 200 degrees Fahrenheit for about 50 minutes. Once done, the rice cools slowly in ventilated mixers that spread it evenly while fans circulate air. Workers monitor humidity to keep the grains glossy but separate. This step must balance softness with firmness so the rice can hold shape without falling apart. As the aroma of steamed rice fades, another process begins. How does simple rice gain the signature flavor found in every sushi bite? Cooked rice moves into large stainless drums for seasoning. Automatic dispensers release a measured mix of rice vinegar, sugar, and salt. about 17 ounces of vinegar per 22 pounds of rice. The drum rotates gently to avoid crushing the grains, while internal paddles fold the mixture evenly. The goal is a glossy, slightly sticky rice with a hint of acidity. Cooling fans bring the temperature down to around 100 degrees Fahrenheit, the perfect level for shaping. Digital sensors read both temperature and pH to ensure consistency across batches. When finished, the rice is transferred to holding bins lined with damp cloths to keep it moist but not wet. Conveyor belts carry the bins toward the forming stations. Here, automation takes control, turning kitchen precision into high-speed engineering. But how does a machine replace the careful hands of a sushi chef? Before slicing, most fish must be frozen to meet FDA food safety rules that destroy parasites. Blocks of salmon and tuna are thawed inside rapid defrosting chambers at controlled temperatures just above 32 degrees Fahrenheit. Once soft, the fillets move to trimming lines where automated knives remove skin and bones with clean, even cuts. Some factories use optical scanners to detect remaining bones invisible to the eye. Slicing machines cut fish into thin, uniform sheets, up to 1,000 slices per hour. Each piece is inspected for color and thickness, ensuring that all slices match the size programmed for rolls or nigiri. Refrigerated conveyors keep the fish between 30 degrees Fahrenheit and 28 degrees Fahrenheit throughout the line. The entire system runs like clockwork, preserving freshness while minimizing human contact. Next comes the moment of assembly. How does the line shape thousands of sushi rolls in perfect rhythm? At this stage, automation meets artistry. Machines layer a sheet of nori onto a flat belt and spread rice evenly across it, leaving a small margin for sealing. Sensors control the rice thickness between 5 and 8 millimeters, depending on the sushi type. Fillings, such as salmon, avocado, or crab, are automatically portioned to within a gram of accuracy. Rollers then fold and press the sheet into a tight cylinder before cutting it into segments. Separate machines form nigiri, pressing rice into perfect ovals of 10 to 15 grams each, while robotic arms place fish slices on top. These compact systems can create more than 4,000 pieces per hour, all identical in shape and size. The quiet hum of motors replaces the chatter of chefs, yet every roll looks handmade. But precision doesn't end here. How do factories slice each roll cleanly without crushing the rice? Cutting sushi rolls demands accuracy down to a millimeter. Conveyor-fed slicers use ultra-sharp stainless blades that move at high speed to divide each roll into 6 or 8 pieces. The blades are rinsed automatically after every cut to prevent rice buildup. Cameras above the line check slice uniformity and reject pieces that are uneven or misaligned. Some systems include optical sensors that scan color, contrast between rice, fish, and nori to detect imperfections. The sound of blades and air jets fills the cutting room as finished pieces slide neatly onto trays. Temperature in this area stays near 40 degrees Fahrenheit to maintain freshness and prevent bacteria growth. Once the last cut passes inspection, the sushi heads toward its final stop. So how does the factory preserve taste and texture until the moment customers open the package? Packaging combines speed with precision. Robotic arms place each sushi piece onto pre-shaped trays, spacing them evenly for presentation. Lidding machines seal the trays under light pressure to protect the rolls. Modified atmosphere packaging injects nitrogen to slow oxidation and extend shelf life. Each tray passes through a label printer that adds production codes, ingredients, and expiration dates. Quality control scanners verify every label before boxing. The sealed packages then move into chilled tunnels maintained at 37 to 39 degrees Fahrenheit, where they remain until shipment. Forklifts stack pallets for transport to supermarkets and restaurants across the country. From rice washing to final sealing, every stage happens in less than 3 hours. The result? Sushi that looks handcrafted but is built by technology, proving that tradition and automation can share the same table, one roll at a time. From the quiet oak forests of Spain to the bustling kimchi factories of Korea and the automated sushi lines of Japan, every product we've seen today follows the same rule: precision, patience, and passion. Each process turns simple ingredients into something extraordinary. Aged ham that takes years to cure, fermented cabbage that stays alive for months, and sushi that's shaped in seconds by machines. These foods connect culture, science, and human creativity in one continuous motion. Behind every bite lies engineering, tradition, and care you can almost taste. If you enjoy exploring how the world's favorite foods are made, subscribe to Captain Discovery and turn on notifications. Each week, we'll take you inside another factory to reveal the hidden journeys of the products you know by heart. What should we uncover next? Tell us in the comments below.